equations, which is different than simplifying expressions. You should know the difference between an algebraic expression and an algebraic equation. An expression, okay, has no equal sign, whereas an equation, it's actually two expressions that equal each other. So if you look at this equation here, it is actually made up of the expression 4x minus 9 and the expression -1. Okay? And what are we asked to do when we solve equations? Well, we're asked to find the missing value of x. That's different than expressions. Expressions we simplified, and then you could calculate them if you were told the values of the variables. Here, we're told that the expression equals something, and we're asked to find the missing variable. That's the difference between the two. And in order to find the value of the missing variable, we need to get x by itself on one side and our solution on the other side. And then we will have our answer. And how do we do that? By a series of opposite operations, isolating x by itself. So if we look at this equation, we want x by itself, but right now there's a -9 with it and a times 4x beside it. I need to get rid of those. Do you remember which one we get rid of first? Divide by 4? Add 9 to both sides. We always get rid of what's furthest away from the x first. So we add 9 to this side to get rid of this. But then I've got to do the exact same thing to the other side to keep the equation balanced. Okay? So now I end up with the equation 4x equals 8. There's only one more step to get x by itself. Divide 4. And again, whatever you do to one side, you do to the other side. And we get x equals 2. And that makes sense because 4 times 2 minus 9 does equal -1. Okay. That's the nice thing about equations is you can always check your answers by plugging it back in and seeing if it works out. So this is kind of your standard two-step equation. We do get equations where there's variables on both sides. What do we do in this case when we've got variables on both sides? Yeah. Take the variable away on one side, and what you're really doing when you do that is you're bringing it over to the other side. So I usually get rid of the one on the right, the variable on the right. So I want to get rid of, remember, this is 4a plus 4a. I want to get rid of the whole thing, so I'm going to subtract it. And it's going to disappear. But whatever I do to one side, I've got to do the same thing to the other. So now I end up with 6a minus 4a plus 2. Well, 6a minus 4a is the same as 2a plus 2 equals -10. And now I've got an equation like the first one we did, a two-stepper, where you just get rid of the plus 2, and then you get rid of the times 2, and you've got your solution. So what's the next step? Okay, tell me what the equation looks like when I'm going to subtract the 2 from both sides in my head. Tell me what the equation looks like when you do that. Good. You don't have to show the step that you're subtracting 2 from both sides. If you want to, if it helps you, by all means do so. But you don't have to. And finally, the last step, we want to divide both sides by 2, and we get a equals -6. Okay. We're going to encounter some equations where we got to do some simplifying first. So we did a lot of simplifying last year. So what I need to do is I want to make, by taking out parentheses and collecting like terms, I want to make both sides of the equation as simple as possible before I start moving things around to get x by itself. So what could I do on the left side here to make things simpler? Get rid of the parentheses by multiplying everything inside by 3. So I get 3 times x is 3x minus 3 times 3, which is 9, and I still have a plus 4x. I can also get rid of the parentheses on the right-hand side by subtracting everything inside. So subtract x, subtract negative 5, which becomes positive 5. I can still keep simplifying both sides. What's an easier way to say the left-hand side? 7x minus 9. And the right side? 10 minus x. Now, it looks like one of the equations that we just did above. We want to bring the x's to one side, then we'll end up with a two-step equation, which we can finish off. So what do you want to do next? Add 1x to both sides so that you're taking it away, or you're taking it away from here and adding it here. And you get 8x minus 9 equals 10. Next. So you get 8x equals 19. Divide both sides by 8, and you get 19 divide 8, which you can't divide cleanly. If you can't divide it cleanly, leave it as a fraction. Just make sure it's reduced if necessary. This can't be reduced, so we're done. We did quite a bit of those last year. And finally, the last type of equation we look like. Fraction equations. Oh, we don't like fractions. One of the first things we want to do when we see a fraction equation is we want to get rid of the fractions and make it into an equation that has no fractions like the previous 3 that we just did. There is a way to do that. Do you remember how? We want to every time you see a fraction equation, you want to clear out the fractions by multiply by the lowest common denominator. In this case would be 8. And we'll see, and sorry, I should put this in here, everything, every term, not just the fraction ones, because whatever you do to one side, you got to do the exact same thing to the other to keep it balanced. So what I'm going to do is I'm going to multiply this first fraction by 8 plus the second fraction by 8, and that will equal the 3 on the right-hand side, which I'm going to multiply by 8. So here's what happens when we multiply. Remember, 8 is the same as 8 over 1. Can't I reduce these? What's 8 divide 4? So really, that reduces to 2. Notice the fraction's going to disappear because there's 1's left. And I don't need to write a fraction over 1. So after I divide these two, I end up with 2 times k, which is 2k. 8 divide 8? 1. Fractions disappear because there's only 1's left in the denominator, and I'm left with 1 times k up top, which just gives me 1k, or k. And then here, it's just 8 times 3, which is 24. No more fractions. Now it's like the ones we've been doing. Well, we can make the right-hand side a little bit easier by collecting like terms. And what will k equal here? 8. Good. Okay, so that's all I want to focus on today. Tomorrow, we're going to start some stuff that is new to you. This is sort of all the algebra review that we went through that's going to be important. It's going to help you do some of the new algebra that we learned this year.